Hello again, Year 8 mathematicians. Some stuff about prime numbers again. I want to have a look at a certain type of prime number. Well, in fact, all prime numbers, follow this rule. If we take a composite number, a number that's not a prime number, you can always express it as two factors, two other numbers multiplied together. And what I've got here is 12 squares. And a very simple thing, what we're demonstrating is that 12 is 4, 1, 2, 3, 4 squares along here, times 3 squares up there. And those are the factors of 12, 3 and 4. They're not the prime factors because 4 isn't a prime number. I suppose I could demonstrate that by saying, look, now what I've got is two lots of 2 times 3. Those are the prime factors of 12, but for this purpose it doesn't matter very much. What we've got here then is 12, which is a composite number, and we can show that composite number with a rectangle made up of a whole number on one side, 4, and a whole number on the other side. 4 times 3 is 12. There's our composite number. Now, if we take a composite number like 12 and remove 1, take 1 away, we're left with 11. And 11 is a prime number. There's no way I can organise these 11 things into a rectangle unless I make one great long string of just 11 of them. One great long string of just 11, well, that's not very interesting. I can't make a rectangle of factors other than 11 and 1 out of 11 squares. I've always got one left over. However I try and do it, I'll end up with, let's try 3 by 3. 3 by 3 is 9. 9. Oh, I've got one left over. I've got 2 left over. No, I can't do it. I can't make a whole numbered rectangle out of 11 because 11 is a prime number. Now, some composite numbers, if I subtract 1, I started at 12. If I subtract 1, I get 11, which is a prime number. But let's take a different composite number. Here's a composite number which is 10. It's 2 times 5. If I subtract 1, I don't get a prime number because I can always rearrange this into 3 by 3. So the question I want to ask is this: which composite numbers, if you subtract 1, will give you a prime? And the other problem is, if I go back to having 10, which is there, if I add 1, do I get a prime or don't I? Well, sorry, let's get that into the view. Of course, if I take 10 and add 1, I get 11, which is a prime. Which composite numbers will give me a prime if I add 1 and also if I subtract 1 from that same composite number? It doesn't work for, say, 16. 16 is a composite number, 4 by 4. If I subtract 1, I don't get a prime. That's 15. If I add 1, I do get a prime. But if I take a number like 18 and add 1, I get 19, which is a prime number. And if I subtract 1, I get 17, which is a prime number. So can you find composite numbers which give you a prime when you subtract 1 and which give you a prime when you add 1? And what you might like to do is do a little graph and show where those composite numbers fall and see if there's any pattern in that. Okay, well, that's another thing for you to do, to look at prime numbers. I will post more later today for you to look at. I'll try and do it during the time of your lesson, but you should expect perhaps to see stuff that's not posted during the time of your lesson, and you need to go looking for it. We're all doing the best we can in difficult circumstances. I am looking forward to projects from people on their prime number work, and there's plenty that you can do, plenty that you can find out. I'll send some more ideas in the form of videos later on, and I will remind you, if you look on the Google Class site, which email address you can send your prime number projects to me on. Okay, thanks very much. Bye.